Good evening, everyone. Today, I'm going to present on the topic of GLIDE towards photorealistic image generation and editing with text-guided diffusion models. GLIDE stands for Guided Language Image Diffusion for Generation and Editing. It is basically a text-guided diffusion models, and it is based on classifier-free guidance and clip guidance, out of which classifier-free guidance is the preferred method. Tasks accomplished by GLIDE are photorealistic generation of images. As we give the input robots meditating in a Vipassana retreat, we can see it was given as an input to GLIDE, and the image generated was highly related to the text input. The next task is image editing through M-painting. We take an original image and a mask image with a text input, and GLIDE generates an in-painted image with what we added as the text input. So let's get into the background of diffusion models. So in forward process, we add some Gaussian noise to the original image. We gradually add that noise until we finally get a pure noise. In the reverse process, we try to predict what noise was added in the forward process by predicting the mean and the variance of the Gaussian noise. And we finally get a new image. This is based on the surrogate loss function that has the true added noise and the predicted noise. Now let's get on to the classic class conditional diffusion models. So these incorporate various conditional information such as class labels or text inputs. So how to embed these class labels? We can do that by two methods. Firstly, you can add the class label at the beginning of the other variables, or you can add the class label at the beginning of each layer of the model. GLIDE implements both approaches together. Guided diffusion model. In guided diffusion model, the image generation is improved with the help of a classifier trained on noisy images at each step. In this, we take noisy images and a class label, we pass it through the classifier, and we get the probability y given xt. And we use this probability with a scaling factor to calculate the new mean of the predicted noise. Effect of scaling factor on photorealism and caption similarity can be seen here. As we can see, clip guidance performs better with caption similarity, and clip guidance also performs better in photorealism. So classifier free guidance, as the name suggests, it does not require a separate pre-trained classifier for guidance. So changes in training that we do to implement it is that we take the class conditional guidance and we replace some of the values with null label. And the changes in sampling are that the model is extrapolated further in the direction of e theta x t given y and away from the xt given null. And we can use a scaling factor here as well, which is always greater than 1. To give it a sense of direction, we basically use the e theta xt given y and use e theta xt null to give it an initial point which is controlled by the vector s. So now we come to clip guidance, that is contrastive language image pre-training. In this, we take text input and images, we pass them through caption encoder and the image encoder, and we calculate the contrastive cross entropy loss that encourages a high dot product when the image is similar to the text input, or a low dot product when the image is not similar to the text input, and we use the gradient of the dot products in the new reverse process mean. So training and architecture. In this, we take a text input and the images, we pass it through text guided diffusion model that contains text encoding as well as visual part. We get the output of 64 by 64 image, and we pass it again through a diffusion model which upsamples the image and gives us the output of 256 by 256 image. So quantitative results, as we can see in the first two ones, the classifier free guidance provides better result when it is compared with precision versus recall, or inception score versus FID score. In the last one, the clip guidance performs better as it is boosted by the clip score. We can also see the results of classifier-free guidance with unguided or clip guidance, and we can see it performs better in the case of photorealism as well as caption generation. And we can also see, compared to DALI, it is preferred by everyone in terms of photorealism as well as caption similarity. Qualitative results, we can see some images generated by Glide, and there is iterative image editing as well. In this, we take an image and an input. We have generated this image, and in the next part we take the mask input as well as an input that says a painting of a corgi on the wall above a couch, and as we can see, the model has inpainted the image of the corgi here. We can use this process iteratively and generate our final desired image. So it has a few limitations as well. As we can see, it can sometimes fail to capture certain prompts which describe highly unusual objects, such as this cat. This Glide was asked to draw an illustration of a cat that has 8 legs. As it is quite unusual, it failed to draw that. Also, it takes about 15 seconds to sample a single image, which is comparatively very slow in terms as compared to similar to Canon. Demonstration of Glide. We take an input image of 256 by 256 image, and then we also input the mask image. We take a text prompt and pass it through the guided diffusion model, Glide, and then we get the output of 64 by 64 image, which is then again passed through upsampling diffusion model with the text input, and it generates a 256 by 256 image which is of University of Toronto, and I have added some flowers in the garden as I felt it was too bland. Thank you.